Very happy to invite our next speaker, Navid Navab, that we are very fortunate to have him for the second time and for the second summer school. It was very interesting to hear his talk the last time around, and I'm very excited to hear his presentation today. Navid is a multi-award-winning, multidisciplinary composer, media alchemist, interaction designer, interdisciplinary artist, researcher, and tabletop cosmologist. Navid currently co-directs the Topological Media Lab, where he leverages phenomenological studies along with other disciplines and practices to inform the creation of computationally augmented sensory environments and to synthesize of new excitable materials at the edge of chaos. His works, which take on the form of gestural sound compositions, responsive architecture, interactive scenographics, and kinetic sculptures, have been presented internationally in different venues across the globe. I would like to invite you to welcome Navid to give us his keynote. Thank you.
Share screen. I'm just going to share my whole desktop. Okay, I think all is well, so I'm going to start. So I am Navid, and I go between art and science and engineering and philosophy. And let me see. So I also co-direct the Topological Media Lab, where we go back and forth between multiple disciplines. And it's important to understand art not as something that's about self-expression or beauty, but as like ethico-aesthetical ways of finding ways of living with each other, humans, non-humans, and social and ecological aspects included, and techniques for doing those, which are transportable to many other domains. Audio. So I've been creating. Oh, okay, I gotta mute my microphone. No.
Then you have to stop sharing and share again.
Okay, I'm going to stop sharing and share again to share the sound.
Go to the microphone or something. There is a possibility, but the easiest is to share.
Okay, stop sharing.
When you share on the bottom left, you have sharing the sound of the
Share screen.
And here you have to click share.
There we go.
Optimize for video.
Optimize for video.
Share.
Share. Okay, so we're back. So I've been creating whole dense palpable spaces where people come together with non-human agencies, technologies to acquire an expressive voice. With a hybrid expressive voice, which is a thing that I've been investigating for many years, and it's transposable particularly to the surgery room, where all of these agencies need to come together to have, again, a singular expressive voice of everything coming together holistically. And there's other domains that apply pretty well, from social sciences as well as artistic research. For example, asking questions that are particularly placed within science, like how do you place a surgeon's ear at the tip of their tool? Or how do you even ask the right question? So the artistic research process mixed with design and engineering allows you to recursively ask if you're correctly asking the right question. For example, if you get a philosophy dissertation, at the end of your dissertation, you end up with a question, not an answer. So in collaborations between art and sciences, these kind of processes could be very productive. So now let me take you to a prelude, a sonic prelude. Let's say you're walking in the forest and you're talking with your friend. They have a boombox, there's music playing, and you can hear a river coming up. And from the stream, you can hear that the variations, the sonic variations in the stream means that there's perhaps a waterfall ahead. There's some breeze in the background, wind blowing in the leaves. And meanwhile, you've been analyzing all of this, listening to your friend, listening to music, and suddenly in the very dispersed ambient sounds of the forest, you hear a sound that could not possibly be quite wind through leaves because it's too localized, moving too fast. So your ear immediately engages in audible diagnosis, zooms in, then zooms into the microtemporal scales of sound and realizes, oh, it's perhaps this is the sound of a nail of a squirrel scratching against a branch. And you were listening to your friend, you were listening to the stream, you made this conclusion within milliseconds and you continued on because you were not in danger. This is the ability of the ear that we could be using within surgical procedures. We made a little conceptual sketch with Nasir, Professor Nasir and Christopher Stapleton around 2014 and 15. I'll play you a sample of it when we were talking about these kind of walks in the forest.
Sound gives that feeling of non-mediation. It can also convey information, meaning, and aesthetic and emotional qualities in interactive contexts. When listening to music, we experience behavioral resonance with physical reality. We are moved by it, absorbed by it, thereby attaining a particular feeling of unification with reality. Our goal is to use this ubiquitous power of sound energy to allow users to intuitively embody big data, to gently absorb it and musically enjoy it at the same time. If we were to transform complex data streams into sound by feeding them through any currently available sonification strategies, then we end up with a cacophonous noise generator, or at best with a series of beeps and clicks that are bound to quickly tire the ear. In order to create socially meaningful, physically engaging, and aesthetically pleasing sonic interactions, an interactive data-driven sound synthesis is required to work in close conjunction with a highly sophisticated musical macrostructure handling system. Such a system can synthesize a balanced soundscape as a calming accompaniment for everyday listening, while providing direct perceptual access to a complex data ecology at all times. By customizing basic musification parameters for any specific context, when data streams reach a critical status, the music can adapt to an attention-seeking status on multiple levels and directions, escalating appropriately to achieve a timely, effective user response. Then simply through attentive listening, the user can simultaneously absorb a multitude of patterns and characteristics within the data for an efficient diagnosis of this critical event at hand.
So since then, we've come a long way as a team and with our collaborations back and forth in Montreal and Munich and Johns Hopkins and various students coming back and forth. But the talk being on sonification, I'd like to give a very quick definition. So sonification in its most simple form is the use of audio basically to convey information. As you see, the definitions are coming on fairly recent. So it's a recent scientific field, but here's, for example, Alban Lussier, composer sonifying his brainwaves amplified through timpanis. And this was in 1965. There's, of course, the stethoscopes, and there's multiple examples across history. The key term in this definition of sonification that you see is information. So what does it mean to convey information via audio? So we don't have to go too deep here, but basically when you look at the etymology of it, information comes from putting something into a forma. But the fact that it's formation, it's a reminder to us that information is not a thing you put into a medium, but it's a process. Information for who? So Gregory Bateson has one of my favorite definitions of information, which says it's a difference that makes a difference. Difference could be understood phenomenologically as a qualitative discontinuity within the perceptual field. But for whom is this difference registered to lead into a transformation? For us, anthropologically centered within the surgical room, it's a difference for perhaps a surgeon, for them to gather information, transform into knowledge of a form or a formation or a process, so they could integrate it within their process. For us as designers, it's important to understand this because often we just think we can put information in things and simplify the ones that don't matter, but perhaps we should work with the user from the start to know what is this process where information is transformed, how are they transformed? Perhaps there's things that are hard to, so to speak, scientifically quantify, but yet they're informative. So as the video also showed, within the surgical field, we're visually bombarded. So a few pros of going sonic is that, well, it's very easily integratable within the cognitive field. You won't have any superimposition problems, as I was explaining in our sonic walk in the forest. It's all naturally taken care of by our perception. In fact, our perception is the interface. So we don't need to make complicated interfaces. There's a difference here a little bit with visual interfaces. Our ear, to be precise, our listening skills is the interface. So the design should really leverage this ability of the ear we were describing. But going back to information, that's if the person has been informed, trained, in other words, in this field, to be able to use this sonic interface. Another interesting thing is the sound is temporal. So it's very fast, very, very fast compared to visual. We go in within microseconds to macrostructures to polyphonically understand patterns of data. So I'm gonna go a little bit faster here, so fasten your seatbelts. There are a few notions that I'm gonna bring with me from other disciplines. As designers, we wanna think about place and sources of sounds. For example, in cinema studies and acoustic compositions and other fields, we talk about schizophonia, schizo meaning separation, and phono sound. So what happens when you electroacoustically separate the sound from its source? If you're in an augmented reality environment, if you put just sound there, you have to really ask yourself, where is the sound coming from? Because our ear is going to have this source binding tendency, wanting to categorize it to see where it's coming from, what is the source, what is impacting what. So as designers, do answer these questions. For example, in cinema, there is great attention to these kind of things of, is the sound coming from the air, from the heavens, from the radio, from someone speaking, are they behind the window? With augmented reality, we get to do real-time cinema or sonic alchemy in a way where we get to put the schizophone and through interactive technology, combine it with an event or a phenomena to re-embody it into the phenomena. And for the user, surgeon, someone else, they can use their imagination to put themselves within the experiential event that the sound's taking place. So as designers, we should really go through this process of this mind map to see what is happening. Is it ergonomic cognitively, or is it inventive, or am I thinking too pragmatically? Because if you're going too far with representational notions of this, therefore that, we're not really using the ear in the way that we were describing of the squirrel's nail against the wood, for example. So yeah, we have to work with all these timescales. if I have my mask here, I have more. So if I rip the mask, oh, okay. So perhaps if you were able to hear, you heard the moment where there was tension and I pulled more. You didn't have to think, you knew, it was immediate. This is at the level of, I don't know, maybe perhaps 50 milliseconds where that happens, where the conversion, that's the intersection that's the most interesting, when frequency and rhythm kind of merge around 20 hertz, 15 hertz. And we should really use these time scales that sound is really good for. I'm not angry at my mask, by the way. This was not a political statement. So we go back and forth between these listening modes. So everyday listening, causal listening, tries to identify the sources. But then when I said pay attention to see if the tension is there in the material sonic event, that's reduced listening. With training, you could go farther and farther, whether it's listening to jazz or sonic textures. So here's some of the guidelines I have for sonifiers out there. So do work with the poetics of schizophrenia. Think about where's the sounds coming from, who's making the sound, what's impacting it. Do not put direction of time in the sound. Sound is temporal. Sound is time. So what you're sonifying is also being put into time. So if what you're working with, and there's exceptions to this always. This is just the beginning point, and it's good to know these and then not follow these rules. And then allow your data to kind of inform the person who's listening on multiple scales of time, which might be musically speaking destabilizing because music has constant time, which is calming, but data perhaps doesn't. So merging this is going to be hard design-wise, but we could hold that and then compose with more difficulty. So I'm going to skip this one and that one. This one's important, particularly avoid visual metaphors because we're such a visual culture. So as soon as we want to think in sound, we think visual and then we try to apply it to sound. For a second, shut down the visual and think sonic. Even the whole field called auditory display yells out that, hey, we're still thinking sonic, which is exciting for sound people to expand. But coming from sound studies and as a composer, there's a lot there that we could benefit from if you think sonically. And lastly, instead, work through kinetics and corporeal products. What is hitting what, what's causing the force, and place the user within an ergonomic metaphor, because we're not composing sounds here, we're composing bodily embodiable metaphors of now my body's hitting a gong, but the gong's turning into wood because the tissue changed, and that means something. Is that ergonomically easy to imagine? So do think about that. And we want to create environments that are lively and calm. So if there's not much data, we should have low complexity. And then as it becomes eventful in terms of the data you're sonifying, then it should become more complex. So we want to avoid sonic pollution by not going to the left of the screen here. Can I know about how much time I have left? 3 minutes. Wow, okay, so I will go over my speaking questions and answers for sure. So there's many different sound synthesis methods. My favorites are for sonification. Oh, my mouse is not on the screen. That's okay. Are descriptor-driven corpus-based concatenative synthesis that we'll get into, and physically informed physical models. There's different ways to categorize sound synthesis methods, but looking at sound texture synthesis, we'll zoom into that 15 hertz, 20 hertz we were talking about. You should probably know about granular synthesis if you want to start synthesizing microsounds. That's a notion where perceptually sound starts having information appearing within the field of perception around 20 milliseconds, 10 milliseconds, and you could call these acoustic quanta or sound particles and you could stitch them together to get other sounds. So it's a very malleable method of synthesis. I'm not going to do the demo. So for example, here's ice cracking driven by pressure sensors through granular synthesis. Here, this one's kind of funny. At a gallery, after the gallery was closed, the janitor was mopping the floor where there was gestural sound water. And it was convincing enough through granular synthesis that created this confusing moment with the blue light, with the gestural fields of activity through camera tracking are modulating about 9 parameters in granular synthesis: grain size, pitch, etc. And that's kind of what we could achieve in this method of synthesis. Oh, it's hard to hear here. Okay, that's okay. And some methods of synthesis lend themselves really well with acoustic sensing, which I will get into in a second, especially with physical modeling and corpus space. And acoustic sensing is happening if you use standard audio equipment even, starting at 48,000 samples per second, but easily people record at 192,000 samples per second. That's a lot of samples. And if you apply all sorts of audio descriptors under temporal and spectral variances and apply machine learning to, let's say, a vector size of 32 samples, that's perceptually easily real time, which means that's a pretty good method of synthesis if you enter it from the knowledge of acoustics, structural vibrations, structure-borne sound, and structure-borne all sorts of other stuff that comes from interactions of materials that go between haptic and acoustic. So one favorite method is corpus, haptically acoustically informed descriptor-driven corpus space concatenative synthesis. That's when the interactions of materials drive tiny particles of sound coming together in time, kind of like these Bob Marley pictures we've seen, but in time put together with grains of sound. And then you could correlate of what you're analyzing with your data. And if your data is acoustic to begin with, and you have a database of sound particles, then you could use a correlation algorithm, KNN, whatnot, to create correlations between what you're sensing and what you could be possibly hearing, which could result in quite rich scenarios where you're giving voice to these haptic acoustic interactions. So for example, it's in 2010, you could imagine what this would mean for tissues interacting with tools, of fingertips interacting with objects on a table with a simple contact mic, sonified. So I could show you one sample of a cutting board. It's like a 10-second sample of a cutting board and a contact mic produced. Or here's another sample of a knife interacting with tissues and bones of a chicken. Quite grotesque, but for the context and concepts of the work, it makes sense. So there were 2 examples of corpus-based content synthesis. I'm going to skip over these slides to get to the end now. We have physical modeling. That's very, very well made to lend itself to good physical metaphors. And a good way of modeling interacting materials by modeling mathematically their resonating objects instead of their sonic parameters. So here you have descriptors analyzed. So when we hypothesized this and it came out so real time, we were actually blown away in 2010. But we were analyzing the sound, and then within that tiny fraction of a millisecond, we were modifying the synthesizer. And this was in real time used even by drummers. So perceptually, when you hit the object, the physically modeled membrane was already augmented based on how you touched it. So this kind of sensing allows you to use audio descriptors, for example, within surgical procedures, to modify based on other parameters to inform the surgeon about other parameters. For example, you could use structural vibrations at every single sample level of, let's say, a screw being screwed into a bone. So that has a lot of information, but yet, let's say there's another descriptor or feature that you want to extract to inform them that they've gone too far. Then you could turn the bone from sounding wooden to metallic using these kind of methods. And that's what we did with, I'm gonna skip this. That's what we did with Hessam when he came to Montreal, and we did some experiments. It got, we did some alignment experiments and pressure where things were changing from being calm to metallic, and some results were good, and we got a best paper award at ISMAR. And here I am at the end with the last slide. If you want to take a screenshot, I wanted to propose that here we are at the verge of a field emerging. We could think of it as a field within engineering, arts, sciences. It's a truly interdisciplinary field. And it's just like at the birth of cybernetics, it's our chance to, before we go too deep, to think together with many disciplines as possible of what's happening. Just from the field of acoustic ecology alone, we could inform ourselves of how the sounds we create inform our environments we live in and ourselves from different disciplines, for example. So anyhow, here's my email, here's my website. Please email me if you have any questions. I'll be happy to share with you my publications, findings, or insights and whatnot. Thank you. Yeah. Oh, that's great.
All right. Thanks very much, Navid, for the very interesting talk. New perspective into the intersection between engineering and arts, in my opinion. And I think we have a couple more minutes for a few questions. And I think I'm going to start by my own question. You mentioned that there's a difference between the auditory and visual perception or the interface for the user. And you said that the interface for auditory feedback is through the perception of us as humans. And I was wondering, like, does that mean that designing systems with auditory feedback is inherently easier, or are there specific challenges that are there, like when working with auditory signals that are not present for visual feedback, for visual sensing, for instance?
Well, one is absolutely the listening skills. Because often you see is what you see. I mean, it could be true also for visual information that a trained eye does much better, that's obvious. But learning how to work with time through our listening skills is something that's not easily transported from visual way of working. So the challenges, the technical challenges are many, probably less interesting to talk about here because that's a thing that we will have challenges, we will solve them. But an interdisciplinary challenge is really working with time across multiple scales at the same time and grasping what does that mean. So we shouldn't avoid using our visual metaphors, but we should also go to sonic thinking and grasp what that means. To be here, but then be connected to something else that's happening there, and to hear things at once, and then having the ability to switch between them so quickly. It's so fast that it's hard to comprehend. And our thinking has a tendency to be object-oriented instead of multi-dimensional. So that might take some, it's very fun. That might take some inquiry, some conversations. So I would say the most important thing is to go to folks in sound studies and cinema studies, composers, also music technology, and import insight from these fields to what you want to do.
Wonderful. Yeah, that makes a lot of sense. And going back to the first question that was posted by Sharif, I think he was mentioning that there is a lot of auditory fatigue already present inside the operating room. And how, so just to quote him, against this background, which again, he's noting the auditory fatigue that the surgeons can experience, how might we bring nuanced and detailed audio like this to the operating room while still letting the surgeons communicate with each other?
So two quick answers. One is if you don't undermine the importance of silence. So if we didn't have time for me to focus on that point in the presentation with the paper we made with Hessam, Rudaki, but if you notice, we were working on an alignment project, and when the things were aligned, we had silence. So you don't always need sound to say things are good. And another pointer again is that the field that really investigates that is acoustic ecology, of how communication, urban environment, ecology, sonically comes together, and they especially focus on communication of species under oceans to cities and humans. So we could go there and understand that technically speaking, well, we have to not add sound. We have to understand what is information within sound, what is aesthetic, what is pleasing, what is nervous, what can be long lasting, and we have to really zoom in. Yeah.
Excellent, thank you. And probably the last question for the interest of time. Would it be possible to relay more information with sound to people who see its color or shape? Would such individual approach make sense?
So people who are synesthetically perceiving doesn't mean that they don't perceive the sound. So the question may be linguistically put weirdly. Or if people don't have the visual field, there's an enormous amount of research being done in that, of how do you convert visual to auditory, auditory display being actually perhaps one of its origins. But the interesting point in this question for me is working across multiple senses. When I ripped my mask, there's a part, or when someone goes on a chalkboard with a nail, are we listening with our ear, or are we listening with every inch of our body? So we could zoom into what aspects of oral perception are inherently haptically processed and which parts are visually processed, and really understand this intersection between the senses and their holistic formation, as in what Professor Navab showed in the first day in Aristotle's fifth sense. We really need to work with this multi-sensory environment, not being in our own disciplines.
Wonderful. Yeah, thank you so much, Navid. I really appreciate the perspective.
Thank you, everyone.
Very inspiring talk. Thank you.